going to look again at simultaneous linear equations. This is either an introduction or a review, if you like, depending on when you watch it. Let's start by looking at what a simultaneous linear equation is. Simultaneous means at the same time. So that means that we have two or more simultaneous equations. That means they're true at the same time. These are linear equations. Both of these are lines. This equation here is a line, and this equation here is a line. Now, we don't have them in slope-intercept form, but we could write them that way. Right now, they're in ax plus by equals c form, standard form. And we're going to look at three ways that we can try to solve these simultaneous linear equations. First, we will look at a graphical method where we simply graph these two lines and see where they intersect. Where they intersect is the point where they're both true, where the point, the x value and the y value, the point where both of these equations are true. So that's the simultaneous part. And then they're lines, so that's the linear part. So we could look at it graphically, and then we could see where they intersect. So let's do that first. Then we'll look at substitution and elimination, two algebraic methods which don't involve any graphing and are more accurate. So how do we graph these lines? Well, there's several ways I could go about this. I could put these equations in y equals mx plus b form and then find the y-intercept and use the slope. I could do that. I could also just start picking points, making up an x and finding out what the y needs to be to make the equation true. I only need 2 points to make a line. So I think what I'd like to do is just look at the x and y intercepts. And those are two simple points that I can find, and there's plenty enough what I need to graph the line. So this first equation here, 4x plus y equals 8, well, the y-intercept means when x equals 0. So if x is going to equal to 0, so at x equals 0, I write that in, 4 times 0 plus y equals 8. Well, that just tells me that y is equal to 8. So I have the point on this first line, 0, 8. So I can graph that here. So that's 0, and then up here is 5, 6, 7, 8. There's a point right there. Let's get another line. Well, now let's let y equal to 0, and that'll be my x-intercept. So I get 4x plus, now 0, equals 8. So x is equal to 2. Now I get the point 2, 0. So that's over here at 1, 2, 0, right here. And I'll lay down my ruler. And since we're trying to actually find a point of intersection, we need to be accurate if we can, not just a sketch, but we try to be as accurate as we can. Let me try that again, actually. Go right through the points we're supposed to go through, so that when I draw my other line, hopefully I'll get the proper point of intersection. Well, let's look at this second one. Let's look at the second equation right here and graph it as well. So do the same thing. I go ahead and plug in 0 for my x value and see what y is going to give me. Looking ahead here, I can see that I'll get an integer value, so that's okay. So here, this was a 4, I don't know why that, and here we have 2x. So I'm going to say 2 times 0 minus 3y equals 18. So here I get 0. I get negative 3y equals 18. So y is going to be equal to negative 6. So now I'm going to get 0 and negative 6, this point right here. Okay, let's do the same thing, and now let's plug y equals 0. And then I get 2x, 2 times x, I don't need those parentheses. 2x minus 3 times 0 is equal to 18. So this gives me that 2x is equal to 18, and so x is equal to 9. So here I got 0, negative 6, and now here I'm going to get 9, 0. So I come out here to 9, which is here, and I get this point. And now I'll connect these dots carefully. And the point of intersection is right here. So that looks about like, let's see here, 1, 2, 3, and then negative 1, 2, 3, 4. So this point here looks like 3, negative 4. Not exactly, really, but pretty close. So that's what I'm thinking my answer is based on a graphical solution. Now, that was time-consuming and not entirely accurate. You have to be very careful how you draw it. So let's look at two ways to solve the same system of simultaneous linear equations. We call it a system because there's more than one of them, and see if we get the same answer. So let's try the substitution method. The substitution method tells us if we have our two equations and in one of them the variable is without a coefficient. The coefficient is 1. Then that's a good candidate for substitution. I can take and rewrite this first equation in terms of y and then substitute it back into this second equation. So this one can be easily rearranged into y is equal to 8 minus 4x. And this is called substitution because now what I do is I take and I substitute it into the second equation. So where this y is, I substitute that in, so I get minus 3 times 8 minus 4x, because I know that's what y is equal to in terms of x from the first equation. And this is equal to 18. And now I do the algebra, and I get 2x minus 24, and this is negative 3 times negative 4x, so that's plus 12x equals 18. Okay, so this is going to give me, I gather my x's over here and I get 14x, and that's minus 24 equals 18. And then putting all the constants on one side, I get 14x is equal to, what's that going to be, 42. So x is equal to 3. And that is, in fact, what I got over here for my point. X was equal to 3. So, well, I'm not done, though. I need to see what y is, and I can plug the x back into either equation. It doesn't matter, this one or this one. I'll plug it back into the first one. That's simple enough. If I do that, I get 4 times 3 plus y equals 8. And now this gives me 12 plus y equals 8. Y is equal to 8 minus 12. Y is equal to negative 4. And that is what my graph told me, negative 4. So I got that through this method as well, which is good. Now I can also check by plugging both of these back into the equation that I didn't use, back over here into this equation. So let's do that just as a check. So let's check that. Let's say, and I've got 2 times, I'm saying that x is equal to 3 plus, or that's actually, it's minus 3 times y, which I'm saying is negative 4. And I want to see if this is equal to 18. Well, this is 6, and then this is negative 3, so it's negative 3 times, it's minus 3 times negative 4, so that's minus 12. Well, so that's equal to 6 plus 12, and that's equal to 18. So that does indeed check out. That is correct. I got a check here, so 3 and negative 4 both work. Now let's do this the last way by elimination, and then we'll be done. So one more time, we begin with these equations, and this system of two equations, 4x plus y equals 8, and 2x minus 3y equals 18. Now this is also set up pretty well for elimination. Elimination is the third method we'll talk about, and it's called elimination because I'm going to eliminate one of the variables. Here I'm going to eliminate the y. I'm going to eliminate the y by multiplying the top equation times 3. So I'm going to take this whole thing and I'm going to multiply it by 3. Why do I do that? Because here I have positive 1y. Here I notice I have negative 3y. If I multiply this by 3, which doesn't change anything at all, it's still the same line, it's just not in lowest terms anymore. I need to factor out a 3, so I'm going to multiply by 3. I'm going to do that so that I can add them. I'm allowed to add and subtract lines, and the resulting line is also considered to be part of the system. So it's just a reworking of the two lines that I already had, and it will yield me a solution. So I look ahead by seeing what can cancel. I could have also multiplied this equation by negative 2, and that would have given me a negative 4 right here, and those would have canceled. But it's easier just to multiply the top equation by positive 3, and then add, and that'll get rid of the y's. So that gives me 12x plus 3y is equal to 24. And then this equation stays the same. 2x minus 3y is equal to 18. All right, so now when I add these two equations, what I'm going to get is I'm going to get my x's added together. It gives me 14x. By design, the y's cancel. Positive 3y plus negative 3y, well, that's 0. And then this is going to give me 42. Well, that looks familiar from before. This gives me 14x is equal to 42. X is equal to 3. Now I do the exact same thing I did before by taking this result and plugging it into either one of these equations. And I've already done that, and I found out here if I plug it into this equation, I get 12 plus y equals 8. So y is equal to negative 4. And I get the answer that way. So those are three ways to do the same thing. Depending on the system of equations, you will determine the easiest and fastest way to find the solution. Graphical solutions are not recommended because, as you saw, that was the most time-consuming, and it also wasn't very accurate. It didn't exactly land where it was supposed to. It was close, and we were able to confirm algebraically that that was, in fact, the answer. The graphical method, though, is good for showing some general concept, and that is that when two equations are equal, graphically what that means is they intersect. And you could imagine, and we will do this later in the chapter, having a parabola and a line, and they could intersect in two places, or maybe just one, or maybe not at all. And if you had an occasion to solve a problem that needed to find out when a linear equation was equal to a quadratic equation, graphically that would be where the line and the parabola intersect. And you could do this with other kinds of equations too, exponential, logarithmic, trigonometric. So this graphical method, even though it's a bit time-consuming and not very precise, the concept is very helpful, especially when you have a graphics calculator. If you need to know that two different things are equal, two different equations are equal, and they don't have to be both linear. Neither one has to be linear, but when two equations are equal, that means their graph intersects. So that in general, that's a very helpful visualization. And with the use of technology, it can be a quick and easy way to solve really complex problems.